Hi dear students, today light reflection and refraction, second topic we are going, ray diagram. How will be the convex mirror and concave mirror, the image formation occurs, and how is the image, size of the image, that and all we will see in this video. First we will see that, see the object is, this part is known as object. Here one example they have taken, dog is sitting in front of the mirror. What we are seeing this side, this is the image. So the distance of the image from the object can be found by a method called ray diagram. You already studied that in previous topic. The distance between the object is equal to the distance between the image from the mirror. Here we will see that some of the spherical mirrors, that how image is formed we will see here. First one, we are observing the spoon in your daily using utensils. The spoon you are using means, in that one you see the your face means it will looks like erect image. Erect image means it is the image of object which is in opposite direction, and it is in the larger size also, and little enlarged image we will see. This one first image. Second image, it shows that magnified image. Magnified image means it is enlarged image we are seeing through the mirror. And some other spoon you will see the inverted image, and another spoon at the end the diagram represents diminished image. Diminished image means it is too smaller, and if the object is in bigger size but in the spoon it is looks like smaller image. So these are all the four types of image we can get from the mirror of spherical mirror, not a plain mirror. Through the spherical mirror we will see erect image, magnified image, inverted image, diminished image. Next, coming to the ray diagram. How will be the ray diagram of the concave mirror? We will see in this diagram. This is a very beautiful diagram. It represents all the ray diagram and all the basic points of the ray diagram of the concave mirror. Already we have learned that here this part what I am showing here, this represents the concave mirror. Concave mirror, it is in the diagram of like this. Here all the terms represented here. The first one is P. P is the pole. Pole, it represents middle of the mirror. And F. F represent focus. And C. Here you will see that C means center of the curvature. How we will see the center of the curvature means, if we draw the full diagram you will get a circle like this. In the circle this is the center one, so it is called center of the curvature. And this is the F, it represents focus, and P means pole. And what this line you are seeing, the straight line here, this represents principal axis. This line represents principal axis. In this principal axis we will get all the center of curvature, focus, and the pole. Already you have learned that focus is the half of the radius. F is equals to R by 2. Already we have seen the problem also in previous video. Next we are coming to the ray diagram. How will be the ray diagram in the concave mirror. Here some of the rules for making ray that is given here. The first rule is a ray of light which is parallel to the principal axis of a concave mirror passes through its focus after reflection from the mirror. It means that the first rule represents any light or light ray. This is the light ray. If you think this is the light ray, it is parallel to the principal axis. What I am drawing here, this is the principal axis, this is the incident ray. Both are parallel to each other. Then if the incident ray falls on the concave mirror, it will reflect from the point F. It will reflect from the point F. Here F represents focus. Then we are moving to the second rule. Here you can see that a ray of light passing through the center of curvature of a concave mirror is reflected back along the same path. It means that if the incident ray, it will passes from the center of curvature, what I am showing here, it will reflect back through its own path. It means that any incident ray passes from the center of curvature. Any incident ray passes from the center of curvature, it will rebound back through its own path. It will comes back to the same path, reflected back along the same path when the light passes from the center of curvature. This is important. This is the second rule. Coming to the next rule in the ray of diagram of the concave mirror, it shows that a ray of light passing through the focus, of a concave mirror becomes parallel to the principal axis after reflection. It is a reciprocal of first rule, or vice versa. We can tell that any ray passing through the focus, we will see that passing through the focus, it will be parallel to the principal axis. It is parallel to the principal axis. This diagram, it represents that one. Any incident ray passes from the focus, it will be parallel for the principal axis. This is incident ray and this is reflected ray. Reflected ray is parallel to the principal axis. Both principal axis and reflected ray are parallel to each other. This is the third rule of the ray diagram. Next, we are coming to the fourth rule. The fourth rule expresses that a ray of light which is incident at the pole, where the ray of light incident at the pole, it will reflected back making the same angle. Where the incident ray is 30 degree means reflected ray also 30 degree. You will get like this. Here we will see the first law of reflection, where incident ray is equal to the reflected ray's angle. I mean, which is I is equals to R. Here we can see where angle of incidence is equals to angle of reflection. This is very important, this rule, where any ray of light passing from the or incident to the pole, then it will reflect back by making the same angle. Same angle means how much the incident angle, that much will be the reflected angle. These are all the four rules for drawing the ray diagram. Next we are further moving towards the four rules for making. This is the way what we have still now learned, that only represented here, how it will be there, how is the importance of that one in the ray diagram. These are all we will study now. In the first diagram it represents that where a ray incident parallel to the principal axis, a ray is incident to the parallel to the principal axis, it means that this is the parallel ray, then ray passes through the focus, ray will be passes through the focus. Then second rule we have seen that any incident ray passes through the c means center of curvature, then it will rebound back in the same path, it will rebound through the same path, so it will represented as reflected or passes through the c means center of curvature. Then coming to the third one, incident ray passes through the focus, incident ray passes through the focus, then reflected ray will be parallel to the principal axis, both principal axis and reflected ray are parallel to each other. Then fourth one, incident ray strikes on the pole, the ray strikes on the pole, it will get the reflected ray as in the same angle of incident ray, so reflected ray makes the same angle with the principal axis. Here some of the cases we will see now. any object any object beyond c, behind the c means it is far away from the c, this ab is the any object that is behind the c, so it incidents on the concave mirror, then it strikes on the concave mirror, it will reflect back and passes through the f, then its image will be getting through the object where we have kept, that line also strikes to the concave mirror, it will reflect back like this, so the image formed is between c and f, this is the image formed, here is the image formed, this is the object. Here this is object, b and a, a and b represents object, here b dash and a dash represents image. If b and a or a and b object is kept behind the c means we will get the image between c and f, between c and f means this is the c, this is the f, I will show here, between c, this is the c and this is the f, between c and f we will get the image, between c and f we will get the image, this is the image and this is the object. So at the conclusion we have to get the conclusion, so position of the image is between c and f. Here I am showing between c and f image is formed, but the object is behind the c, and nature of the image is, first one is real, it is a real one and it is inverted, means as the object it is inverted and diminished, it is a lightly, it will be looks like small. Then at another case, object is at c means here already object is at c position only, one object we are kept that is represented by AB means the image also we will get in the A dash B dash as in the C only. We are getting the image at C only. We will see now here if any AB is kept on C, it will reflect back on the focus. Exactly all the rays are passing through the focus only, and it's another ray also it will passes through the focus, then it will rebound back. We will get the A dash and B dash at the C means center of curvature only. So position of the image at C only, object is at also C only. Any object we are kept on the C means center of the curvature in front of the concave mirror. At the center of curvature we are keeping object means the image also we are getting at the C only. It represents that it is having distance of focal length. Focal length is twice, two times the focal length. Focal length means if the focal, this is the radius, r is equals to 2 times the f. Already we have learnt. So its properties are object is at center of curvature, then image is at center of curvature, nature of the image is real, it is a realistic one, and inverted and same size because the distance between A and B is same from the concave mirror, and A dash B dash also having same distance. It is represented by radius. Center of curvature to the pole is equal to the radius. So radius is equals to 2 times the f. So image at the C, the distance between the image and the concave mirror is represented as d means the object and image distance both are having same distance, and it looks like same in size also. Next we are moving towards object between F and C. Here the object between center of curvature, object between center of curvature and F, here we can see that object is kept between C and F. So it will reflect back in the focus, and the ray of light also it will reflect from the focus. So the you will get the image A dash B dash behind the C. You will get the image behind the C when you keep the object at B, I mean between C and F, A and B as the image object represents. So it will shows the image behind the C that is represented by A dash and B dash. What I am marking here, you can see this one. So properties of this one, when we kept between F and C, any object is kept between F and C means position of the image at behind the C, and nature of the image is real, inverted and magnified. Magnified means little enlarged image we will get compared to the object. If the object is small size, the image will be larger. Next we are going to the next case, object at F. If any object we kept exactly on the focus, here focus we are showing here, exactly on the F we kept the object means the ray of light will pass us through the F only, but we will not get the image. We will get the image highly magnified, I mean it is enlarged one, too much far away or infinite distance we can see the object. So if object is at F, the position of the image at infinity, we can't get the image, it will be getting on the infinity. Infinity means too far away, we can't judge the image size also, that much big will be there. Nature of the image is real, and it will be inverted and highly magnified. Highly magnified means it is in the larger size it will show, and it will be big size. Next concept is the object between P and F. It is also one of the case. object between P and F. P means pole and F is focus. Between focus and pole, we are keeping a object means we will get the image. It is magnified, but we will get in the back side of the concave mirror. It will looks like that. So it shows that when we keep the object between pole and focus, we will get the position of the image will be behind the mirror. Behind the mirror means it looks like the back side of the mirror. It will be there. Original position of the object will be back side of the mirror. It looks like that. And the nature of the image is virtual. Virtual means it is behind the mirror and it is like same. It will feels like that same. And A and B is the object, and it is looks like A and B also in the image. So it is called virtual. And erect and magnified is it is will be the bigger size compared to the object size. So today we will end for this one. Thank you. Please subscribe to our channel.